This is the final project, simulation recreation of the pick and place control bench system. On the left side here we have our TIAPortal, and the right side, this is our PLCSIM. It just has tags here now. But on the left side, our system begins with network 1, which essentially just runs the system, or runs the conveyor belt, and technically the system with that. And it starts whenever you press the button here, which I've done already, and it latches on to keep running, and only turns off upon reaching our limit of 10 objects sorted, which is our done network, or done bit there. Network 2 is our slider, which dispenses the objects, and it has a couple different configurations of when to actually dispense, or at least start the dispensing process. We'll go back to that later, but what's important is that whenever the system starts, it automatically dispenses ones to kick things off and to make sure the system keeps going. The ready to dispense, this hole here, is an additional thing to the system, which essentially makes sure that the system actually has the object to dispense, and if not, it warns the user. That will be covered in a later network at the bottom. But upon the sliding out, it resets the ready to dispense, indicating that an item was dispensed, and resets the slider as well to put it back into the neutral position. The rejection process, which will activate whenever the reflector or was a metallic kind of visual sensor indicates that one of the objects is reflecting light back, which will activate the rejection paddle, or if the user on the HMI presses the reject button while the system is running, it will also throw off the rejection paddle. Here's our object counter, which will basically count whenever an object has been sorted. So if the object has been rejected, then it'll count that. Or if it hits the photo gate, which means that the object was accepted, being that it passed all of the other rejection points of the assembly line, that means that it's also been sorted, and it goes towards this counter, and upon reaching 10, it finishes the system, and the system or the conveyor belt turns off, and the system is completed. For network 5, we have our pick and place robotic arm, which is activated by the photo gate, and upon doing so, it sets the pick process, which are all separated to make sure that the robotic arm positions don't interfere with each other, so that the system or the arm movements are fluid and go in the right order. In the pick process, the arm moves forward, down, and then opens or closes the gripper, which indicates that it has got the object. In doing so, it resets the place process, or it sets the place process, it resets the pick process, going to the next section of movements, in which the object or the arm goes up, back to this home position, goes down, and goes into the place, or the home process resets the place process, in which it will open the gripper, dropping the object, and return back up after resetting home, meaning that the arm process has been done and the object has been moved from the assembly line drop-off area into the assembly area. Network 6, this is the additional add-on to the program, and this is what makes sure that the entire process sees whether or not there's an object in the object holder dispenser. And in doing so, if it's ready to dispense an object, being that up here in network 2, either the robot has returned the home position or the rejection paddle has been activated, of course, after only if there are less than 9 objects that are being counted, to make sure that there's not another object ready to be dispensed after it's already rejected its 9th one or its 10th one. So make sure that the system doesn't start off with system ready or object ready to dispense, which shouldn't matter, but it keeps everything cleaner. Or within system starts, which technically can happen, but usually you're going to have it full before you start off. And here, if it's ready to dispense, but an object is not detected and the system is running, then after 10 seconds, it'll tell the user that is out of objects, which down here is an additional thing to tell the user. It's actually one of the only ways to actually send an alert to the HMI, since you need a integer input or integer tag to send to it. So essentially sends that by telling the state of the system. By if it's 0, that means an object is in the dispenser and is being dispensed, or if it's out of objects after the 10 seconds, then it'll set to 1, saying that the object is, or there's out of objects and it needs to be refilled. Down here we actually have our HMI, but sadly because there has been issues throughout this course of getting the HMI to connect with the PLCSIM, nothing actually works within the tags of each other. But we actually have an alert system to show that the buttons indeed do something. Right here would be where the object count would show, but it's just pound signs here. We have a home screen to make sure that if the system starts or the HMI starts up on the home screen, there's a way to get to the operations screen and back and forth. And there's a reject button, which also doesn't work. But we can see here, just as kind of like another way of showing that it's actually set up properly, we can go to reject here. Of course, we gotta close this first. We'll go into properties. We'll show down here, we can go into vents, and we can see here that press and release does set and reset the reject button, as well as the start, and in this case the done. And the home screen goes through, so the HMI setup just sadly isn't operational. Before we press the start button, we're just going to set up the arm to its home position, which is back and up. And we're going to fill in the dispenser slot with this, so that way we won't have any errors towards the end. Which now, since it's ready to start, we can just start it. Which will automatically turn off right away too, and you can see the system's running here. And because we already started, it is ready to dispense, which activated the slider. And to make sure that the object is completely dispensed from the dispenser, we have a slider in limit, which that will activate, which will reset the ready to dispense bit, and means that the object is technically on the assembly line going through. Here, if it was a metallic object being dispensed, then it would hit the reflection detector here, which in doing so will activate the rejection paddle, which as soon as the object is knocked off the assembly line by the rejection paddle, our reflection detector won't detect anymore and will turn off. And as we can see here, we have 1 because of our counter here indicating that 1 object has been sorted. And after the rejection paddle is hit, we go again to slider or network 2, and we can see that because it's less than 9, which this case is just to make sure that there's not an object counted after is knocked off, so you don't automatically push one off after 9, because you want that one to be your last one. But object's ready to dispense again. We'll go here to our slider limit. We'll make that true. Object is on the assembly line. In this case, we're going to make sure it's a normal one. So as the object goes through, it'll finally hit the photo gate and get into the assembly line, or the assembly area, which we can hit the photo gate here. When this becomes true, we start our pick process. And by the way, the photo gate, because we have it set to the counter, the second object is technically an accepted object, therefore it goes towards our counter, but nothing is actually ready to be dispensed yet. During our pick process, we have, right now it's in home position, but the robot's going to be moving forward first, So we're going to remove the backwards limit, and now it hits the forward, which now indicates it to go down. Now, as soon as it goes down, it sets the gripper, which will hold onto the object. It'll reset the pick process and start the place process, which now wants the arm to go up. After going up, it'll want it to go back, and then it wants it to go back down, in which case, by doing so, it'll reset the place process, and now it'll set the home process, in which it opens up the gripper so the object is now in the intended slot, and it'll tell the robot to go back up, and upon doing so, resets the home bit and indicates that the robot is done. Now here is ready to dispense. The slider is already set, and it's ready for the next object, which in this case, we're going to say after the object is dispensed, that was our last object. So we set the slider in limit, which will reset the slider. The object is now on the conveyor belt, and this one, let's just say, is also rejected. So before we do that, we'll look down here, and as soon as this is dispensed, it sees that there's no object, but is ready to dispense the next object. So after 10 seconds, it'll power the out objects, and down here we have ready to dispense true, but also out of objects true. And for some reason, it also likes to extremely, disorient the numbers for some reason, because I guess the entire address is just a different bit and it interacts really weird. It'll be even weirder in the next video, but as you can see here, this set is also 1. And the way to actually reset all of this is to put objects back into the system, which in doing so resets all of this, is back to false and out of place, and the object's number sorted, it actually returns back to normal. And to complete the process, we're just gonna kind of go through it quick again. See, slider in limit. We're just gonna pretend next all these are gonna be rejected. Doing so, we see that the number counter at the bottom is going up. We'll just keep doing this. And we see as soon as the reflection releases this one again, we see here it's no longer ready to dispense, but there's an object onto the table or onto the conveyor belt. So even if it reflected it again, which if we see this one last time, I believe the slider's already reset, yes. So in doing so, now here we have our 10, but nothing's getting ready to dispense. And just to finish it off, we'll go through the arm motion real quick here again. The arm's gonna go from back to forward, gonna go up to down. Oh no, wait, sorry, I forgot the photo gate. We'll just reset the bot real quick, and here we'll activate photo gate, which will start the system. And in doing so, we have reached our 10, which I think I've pressed another button, so right now it's at 11. But we're gonna go back to forward, down to up, or up to down. We're gonna go back from down to up. We're gonna go forward to back. We're just gonna follow this real quick. Up to down, then we're gonna go down back to up, and the system's done. And if we can look up top here, our system is done, therefore the conveyor belt stops and the rest of the system also stops, which completes our 10 object sorting goal. And that should be the first program here. This is the second part of the project, which uses majority of the same code and simulation as the previous one, but is retrofitted with, instead of assembly robot, it has a sorting system which will sort the objects that are being dispensed by a dispenser going through the assembly line, and depending on their size, it'll be sorted in 1 or 2 different bins, which, as we can see here, the majority of the code is the same. As we go down here, we see additions to the counter, and I think explain the next part will better explain the counter. Here we have the sorting size system, which, given by a load cell sensor, which feeds into a converter, converts the current output by normalizing it and then scaling it. We get the weight of the object, which in this case is in grams. Since it's a micro load cell, or at least we're assuming it is, our maximum is 780 grams. So about 2 pounds or so are what our object's going to be kind of weighed against. And here we have the size sorting system, which can tell if an object is large or not, which in this case we just have 1 bit saying whether it's large, and if the bit's on, it's large. If the bit's off, then it's a small, to not make anything too complicated. In this case, if it's over 455 grams, which is basically 1 pound, we consider it large, or we reset it. And this is the main system that's controlling everything, or that's controlling how the system sorts, is when the photo gate is activated, which is right when the object falls off of the conveyor belt. If the object is considered large, then the chute will be set to be pushed out, which here is kind of a simple design drawing of the intended applicator. If I can get this to fit as well. So this would be where the assembly arm was, right off of the conveyor belt. And if the object is large, then the chute, or in this case sorting chute, will be extended outwards, which will which will have the entire conveyor belt finish or end off here, which will then push the objects outwards like this, and kind of away like here, you can see. And if the object is considered small, that it resets the solenoid valve to push back into neutral or fault or false position, and the object will come out here into a small bin. And this is kind of just an example of how it would work. Either bounce off or it'll just slide off. And that way too, by setting the system, you don't have to change back and forth depending on if you have 3 small objects in a row. It's less strain on the system, especially the solenoid valve extending out and going back in and out. So multiple objects in a row will result in less strain, less maintenance required on the applicator, and it's just more efficient that way. And here is our counter. This is the same counter as in the beginning, which also, before I forget, in the original system, this was home, because whenever the robot arm was set back to home, it was ready to dispense the next object to make sure that the arm wasn't trying to be given too many objects more than it can handle. But in this case, since all it is dropping the object off the end, if it does make it to that photo gate, then it's okay to have the photo gate as the ready to dispense, so the system can still flow smoothly and fast without overloading the system or how much it can handle. And for the counting system, essentially it's the same counter as before. Nothing's changed here, but I've added 2 other counters too, just to show how many large and how many small items have been sorted through. That's kind of just a small additional thing to it. The HMI hasn't been touched. Sadly, still doesn't work, so there wasn't much interaction I could have done anyways. But the sorting, or the object detection system from before is still implemented. So by retrofitting it, we really didn't take out anything except for the arm. So that's kind of the intended goal. And we're going to see if this will run correctly. We'll start. Oh yeah, we'll monitor the system real quick. While we're doing that, we're going to show that there's objects detected in the system, so they're ready to be dispensed. Is this being monitored? Okay, just had to reconfigure to the system real quick, just had to upload it to PLCSIM. I don't believe I changed anything, but must have been something I didn't like. But back to the system, we just have it. Okay, these are gone. Okay, now we're finally ready. I just had to reload in the tags. So the system has been started, which we can now turn off and it will remain started. They're already ready to dispense, which it does. The slider has pushed the object onto the conveyor belt, which we can tell has been true. So that resets there. The object is on the conveyor belt. And for the first one, we'll just do another rejection thing, just show that everything's working. This system is ready to shoot out another one. Ready to spin, so we're just gonna say slider end limit has been reached and is back on the conveyor belt. Now since it's reached to the end, which here it's a little unpredictable just because we're not working with a real sensor. So for the load sensor, we have our usual current limits, but in this case we don't have much control over it. So you'll see down here it's the weight of the object, but it's not really ever consistent. So sadly we're just doing our best, but as you can see here, it's small because it's less than our 1 pound limit. And here it's big because it reaches over. And now you can see here, if I just keep clicking this, there's really no control and it messes with all the other tags in the system. So I try not to mess with that too much. Because see, photo gate is true. I have not pressed that yet. So just to show, I'd rather not touch that if I don't have to. Because even pushing in these, you can see changes the value here. It's a lot of weird interactions. I might just be the weird addressing things I had to do to make sure and it was an integer or something else. But yeah, that's definitely something I could not figure out. But going on with the system, our system is considered large, which if we go in here, we have nothing counted yet, nothing has been sorted, besides the previous one that I know of, unless if all this weird stuff just happened. Because, let's see, so it's large, it has hit the photo gate, we assume, and our shoot direction is false, which here, since it is large, we have the shoot direction here. Once it hits the photo gate, it will move over, setting it. The solenoid valve will extend, and we get an additional counter to large sorted, which upon the gate closing, we also get a counter for objects. Let's see, dispenser state. Let's see, objects. Oh yes. Where is it? Objects dispense? No. Objects sorted. I think that's another thing too. Oh yeah. That's what it is. This is messing up. Yeah, it's a lot of just weird things trying to move around the whole load sensor output. But we're just going to go through it again just to show one last time. Let's see. we're just going to do this just to show that there's going to be one pushed out. There's now an object being pushed out onto the assembly line, and we're going to change the load value, hopefully get a small value this time. That'll work. It's below everything. I don't think any of this stuff has changed, luckily. So now we can see that the large has been reset, which for some reason it's not resetted here. It's a lot of weird stuff trying to do all these things. But if the photo gate is tapped on, then we'll see that it is reset to the previous position with the chute. Therefore, the objects fall into the small bin, and we get a counter for small sorted. Nope. Oh, that's the point of it, if it actually worked, but just moving around the slider screws up the entire system, which it's hard to show without moving the slider, so I can't really do that. But if we were using actual sensors with correct values and nothing was interacting with each other in weird ways, then the system should work correctly and be a successful retrofitting, or was it retrofitted from the previous system.